Hi dear students, today we have started a new topic, that is energy, and in a new format. So here in this video we have just tried it to do in presentation form. So let's see whether you like it or not. Okay. So when we are talking about energy, so energy means whenever the things comes to our mind that some extra thing that is with us so that we can do something, whatever it may be. So one by one thing we have to see here, as well as we have to measure the energy. Let's see. So talking about the first thing, that what we just want to learn, that is the topics. So first one, we have to learn what is energy, and then we have to discuss that what is the work done and how we can able to measure work done. And before that, we have to learn what is the relation between energy and work done. Definitely whenever we have defined a quantity like work done, we have to get the unit of work done and we have to define it, the relation of work done and energy, units of energy, different forms of energy, and the main discussion we will just do little later, that is two forms of mechanical energy. Let's start. Okay. First thing, whenever we are talking about the definition of energy, it is told that it is an indirectly observed quantity. It is not such a quantity which we can directly observe, just like length. We can directly observe the length. Just like mass, we can directly observe it. But energy is a quantity which we can able to observe indirectly, and we can observe it by which process? Now we can observe it, that it is written here. It is often understood as the ability of a physical system to do work to other physical system. Physical system means it is a constitution of some instruments, some objects, that is known as a system. Or it may be simple object, a man, a car. This all are taken as physical systems. So whenever we have to measure energy, we have to measure it by a different way. There we have to do some work, and by seeing the ability of doing work, we can able to measure energy. That means if you have energy, you can able to do some work in a simple thing. Okay, so we can say that it is a quantity property where it must be transferred to an object to order to perform a work. Simple thing, both the statements are giving you the same thing, that is if you are having energy, then you have to do some work. So as directly we cannot able to measure energy, so that if you can able to do some work, then you have energy. If you do more work, so you have much energy. If you do less work, you have less energy. Okay, in another way also, if you can do much work in very less time, then also your energy is more. Clear? So step by step we will discuss here. So now our target is, as it is told, that by the measurement of work we can able to measure energy. So our target is what is work done and how we can able to measure it. That things we have to learn. Okay. So next thing will come, that is the work done. So how can we able to measure work done and what is it? It is told that whenever you apply a force on a body, and if the body displaced, then it is told that you have done some work. Assume I am applying force on a table and the table displaced, then it is told that I have done some work. But assume I am just applying force on the wall. Okay, definitely the wall will not displace. That means there is no work. So to do work, we have to displace the body. Now the question has come, okay, the definition we have got, but how we have to measure it? So for that reason, come to the second point, that whenever you are applying a force on a body and the body is displaced, then the force and the displacement is done by the body. Its product, means its multiplication, is known as the work done or the measurement of work done. See the diagram, it is given. So initially the body is at the position A, then you apply a force F, and then the body is gone to the position B, and you see the displacement is S. So our work done, it should be W equals to F into S. Keep that thing in mind, that W equals to F into S. It is a very important equation. As we have defined a quantity, definitely we should learn about the units of it. So how we have to get the unit? So as we have learned that work done equals to force into distance or the displacement. So here unit of work done equals to unit of force into unit of distance. You see, unit of work done. So in previous part, whatever we have learned, that work done equals to force into distance moved in the direction of force. Okay, and in this case, whenever we have to find the unit, then what will be the unit? Unit of work done will be unit of force into unit of distance. What is the unit of force, or what is the SI unit of force? We know it is Newton. What is the SI unit of distance? We know it is meter. So SI unit of work done should be Newton into meter, and that one we have defined by a new name, that is the name of a great scientist J.P. Joule, that is Joule, and which is denoted by capital J. So SI unit of work done is Joule, okay, which is denoted by capital J. Now if anyone asks us that how we can able to define 1 joule of work. So to define 1 joule of work, you see one definition is given, that is 1 joule of work is said to be done when a force of 1 Newton is applied on a body and the body covers a distance of 1 meter. By application of force of 1 Newton, if the body displaces by 1 meter, then our work done should be 1 joule. Okay, so that is the SI unit of work done. Not only the SI unit, there must be a CGS unit. So CGS unit of work done, it should definitely the CGS unit of force into CGS unit of distance, because work done equals to force into distance. So CGS unit of work done, that is equals to CGS unit of force into CGS unit of distance. So what is CGS unit of force? That is dyne. It is already written. The CGS unit of force is dyne, and CGS unit of centimeter distance, it is centimeter. So our work done should be dyne into centimeter. Clear? And this dyne into centimeter, it is given by a new name, that is known as arc. And you must be asking, sir, what should be its symbol? Its symbol is also arc. Okay, in case of dyne also, you see it is given here. In case of dyne, here also the symbol is also dyne, and in case of arc, the symbol is same, that is arc. Okay, so how much work is known as 1 arc of work? And that definition is also given, that 1 arc of work is that when 1 dyne of force is applied on a body and it is displaced by a distance of 1 centimeter, then it is known as 1 arc of work. 1 dyne of force and the body displaced by 1 centimeter. Clear? So that is our unit of work done. And now we have to go for the next very interesting thing, that is, as we have learned about work done, then what is the relation between work done and energy? So see the first statement, it is written as a heading that energy is capacity to do work. In the first starting, whenever we have told that energy is a physical quantity which we cannot able to measure directly. we can measure it indirectly. So when we have to measure indirectly, so indirectly what thing we can measure? We can measure work done. If I measure work done, then how much work we have done, I am having that much amount of energy. So what is your work done? That will be your measurement of energy. So here it is written the relationship between work done, energy and force. So definitely to do a work you have to apply a force, just we have seen in the previous part. And whenever you have to do some work, definitely you will lose some energy or you will possess some energy. These two things will happen. If anyone do some work over you, then you will gain energy. And if you have done work on any object, then the object will gain energy and you will lose energy. That is the simple relation. If you are having much energy, then you can do much amount of work. Okay, if you have less energy, you can do less amount of work. So that's why it is written, without energy we cannot able to do work. Work is done when you apply a force and that causes a movement of a stationary object, and there is a change in speed and direction of the moving object. Simple thing. You are applying force, that's why the position of the body is changed, and then you have done some work, and that work will be your measurement of energy. Here I have shown you two diagrams. You see, in the first image, a big ball is taken to a hill by the boy. So whenever the ball is taken to the height, the boy is doing some work on the ball. Definitely, because you have to push it continuously to lift it at a height. So whenever you have done you are applying some force on the ball, you are doing some work on the ball, and whatever the work you have done, that work is stored on the body as its energy. Okay, that work is stored on the body as its energy in the first image. And in the second image, you see the boy has just pushing the ball down to the hill, and that means the ball is rolling down to the ground, and as it rolls continuously, definitely if anything comes in front of it, it will just thrash. Okay, why? Because that work what the boy has done over the ball, that will stored on the ball as its energy. And now due to that energy, when the ball goes down, using that energy, the ball is doing some work. It's exactly vice versa formula. You have done some work on the ball, whatever the work you have done, that is stored on the ball as its energy. And when you roll the ball, then due to the energy stored on the ball can do some work. Clear? That is the relation. So in a general way, if I want to sum up this portion, we can say that work done and energy are equivalent to each other. We cannot say it's equal, it is equivalent. So if you have energy, you can do work. Simple thing. Okay, going to the next one. So as we are talking about energy, so we learn little about the units of energy. So as the unit of work done is joule, so SI unit of energy is also joule. So you can say that both the physical quantity is same. What is the definition of 1 joule of energy? 1 joule of work done we have seen. What is 1 joule of energy? So it is told a boy is said to possess a body is said to possess an energy of 1 joule. Work is done to bring the body in the state, that is, a force of 1 Newton moves a body by a distance of 1 meter in the direction of force. You might be thinking, sir, what is this? If you are doing some work, I have just told that will store as energy. That means if you apply force 1 Newton to a body and it is displaced by 1 meter, then how much work you have done? Now 1 joule. and that 1 joule of work is stored on the body as a form of 1 joule of energy. That means if you have done 1 joule of work, then 1 joule of energy is stored on that body where you have done work. Okay, so apart from this also, there is another unit of energy. Mainly we can use it as a heat energy, as a unit of heat energy, that is known as calorie. Okay, and which is denoted by cal. Okay, and what is the relation between calorie and joule? It is to 1 calorie equals to 4.2 joule. Okay, and one larger unit of calorie is also there, that is 1 kilocalorie. Kilocalorie is larger than the calorie. 1 kilocalorie equals to 1000 calories. So these are the units of energy which is generally we have used. Okay, and calorie I have already told, it is mainly used to show the heat energy. Okay, and in joule we can say everywhere in form of heat energy or another energy we can use joule as a form of SI unit. Now, as we have discussed, we all know that from the very much childhood we have learned that around ourselves there are different kinds of energy, different types of energies are there. Means the energy that is just come in front of us in different form. So first one is mechanical energy, second one is heat, then light, chemical energy, sound energy, magnetic energy, electrical energy, atomic and nuclear energy, and last solar energy. So you might be saying, sir, heat energy and light energy is there, that means solar energy is basically that thing. So the solar energy I have just kept here, so it is definitely a light energy and heat energy from sun, and as nowadays it is very much needed because we all know about the environment pollution. So solar energy we need very much, so that's why I have kept solar energy as a form of a separate form of energy. Okay, so now we'll discuss one by one. Let's see. Mechanical energy, what is it? So whenever I have kept a body in one place, so we know if I have not taken it from there, the body will remain in that place only. If I have taken this calculator, assume I have taken it to a height, assume I have kept it here. So if I have not moved, then the body will kept here. Assume instead of my hand there is another book or something is there. So due to the position of the body, due to the rest, the body will possess some energy on it, and by that it can able to do some work. So now you might be asking, sir, due to the position or due to the rest, how it will get some energy? Simple thing. If I have just throw it or leave it from this side, if it is just coming downward, then it will break, or either on which thing it will fall in, that thing will break. Then from where it will get that energy for which it can able to break the object it is kept here? Simple thing. Due to the rest, the body has a energy. Not only that, due to the motion also, the body should possess a energy. Here I have shown you two images. In first image, the man is just stretching the archery. Okay, so whenever the bow is not the arrow is not released, the arrow is static on the bow, so in that case the bow should possess a energy. Due to what? Due to this stretched string, and whenever you release it, the bow will move. So why the bow can able to move? You can say due to the stretched string you have stretched it. So whenever you have stretched it, it should have some energy possessed in it so that it can able to do some work. That is known as a mechanical energy. Not only that, whenever the body moves, then also the body should have an energy. Here you say the boy is moving. Not only that, whenever you have thrown a stone, you are just somebody is shooting, by his gun or her gun, then also the body possesses energy. If a car moves, it should possess energy. So that is mechanical energy. Here I have just mentioned two different energy. You see, potential energy and kinetic energy. We will discuss it later, but due to the position or due to the rest, what energy is possessed, that is potential energy. And we have seen the stretched bow, it is possessed potential energy, and when the body is moving, due to the motion, the energy is possessed in it, that is kinetic energy. A very simple thing. Coming to the next thing, heat energy. So it's a very common thing we have seen around ourselves, that whenever your mother is making rice, that time the lid that is kept over the container, whenever almost the rice has made, the lid is just jumping up due to the pressure of the vapor. So from where this energy has come? Okay, if I'm talking about the pressure cooker, so the pressure cooker, the weight, the steam weight, we can say, whenever the steam is filled, the steam weight is moves up with a whistle. We have told na, city. So where this energy comes up? That energy comes up due to the heat energy. We can say heat energy that transferred from one body to another body as a result of different temperature. We all know temperature. Assume some object, it should have a temperature of 50 degrees centigrade, and another object, assume it is a temperature of 10 degrees centigrade. If you keep it together, so definitely from 50 degrees centigrade to 10 degrees centigrade, some energy will pass, so that the object whose temperature is 10 degrees centigrade, it will reach high. That energy is heat energy. Okay, in this two images, you see, first one I have shown you an image of a kettle. Okay, so in kettle we have seen the lid of the kettle, it will often jumps up whenever the steam is totally filled up, that is due to the heat energy. And using that phenomenon, or using that physics, scientists made the first steam engine, and using that steam engine for a long time, we know the modern trains, it move. Okay, but nowadays the electricity line has come, but till now in hilly areas this steam engines are used. Okay, using heat energy, light energy. So light energy is such a energy, we can say, which we can visible, means whenever it incident over an object, that can be visualized by us. That is one kind of energy, we can able to visualize that thing. But using that energy, definitely what works we can able to do. So nowadays using light energy, we can produce electrical energy also, that we'll discuss later. Using light energy, we have seen in that, we have shown you in the image, the photosynthesis, the plants can able to make their foods by using light energy from the sun. Okay, so light energy is also very much important part of the energy. Okay, coming to the next one, chemical energy. So simple thing, whenever some chemical reaction is occurred, in that time the potential energy stored in the arrangement of the atoms and molecules, because we know all the object is made by the molecules, and inside the molecules is made are made by atoms. Okay, so whenever some reactions are occurred, then these energies are coming out. It can comes out by different form. It can comes out by heat energy, it can comes out by any sort of by light energy or something like that. Okay, by electrical energy. But this is released, that the potential energy of the atoms and molecules is stored on an object. Here I have shown you 4 images. You see, first one is the battery. In battery, we know there is some paste inside the battery. What paste, how it has made, that you have learned later. Okay, simply some chemicals are given, and using that chemical we can convert it into current or electrical energy. Next one, burning of coals. So whenever the coal burns, that time some energy is emitted as a form of heat energy, as a form of light energy, and we can use that energy in various formats. That is also a chemical energy of the coal is released. Not only that, the car, the bikes, in that we can put petrol or diesel, the oils. So that oils, using that oil, that car or the bike can able to move. Okay, they can get a speed. So they should have a kinetic energy by using that chemical energy of whatever we are taking, the oil. And candle, at the end, it's a very important thing. So candle, it is made by mainly carbon and hydrogen compound. Okay, the wax we are talking about, and when we burn it, we get light, we get some heat energy by just converting the chemical energy of it. Clear? So these are the chemical energies. Sound energy, day to day, every day we are inside the ocean of sound. Various kind of sounds we have heard around ourselves, and whenever the sound is produced, the question has come, how does it produce? So here you see, first one, guitar. So whenever you just plug the string vibrates and you will get the sound. Whenever you have to blow here in the saxophone, the air inside the saxophone, okay, it will vibrate. In flute, the air inside it vibrates and you will get sound. So the sound means a vibration, and that vibration definitely produces an energy, that is sound energy. Okay, and we have heard always around ourselves, magnetic energy. Magnet we have all seen, and if I am not wrong, I have shown you once whenever you are in class 6. Okay, I think you have not seen the previous class. They have seen that magnet. We all know, we often played with magnet, that it's a metal which can able to attract some another metals, okay, or which can attract some magnets also. That is a form of energy. That energy is possessed as a form of magnetic energy. There is various use. In the image you see, whenever we have to take huge amount of iron or scrap iron at a height or at another site, that time we cannot do it by our hands. We can use that magnet, because you know that iron is attracted by the magnet, and that is one kind of energy, that is magnetic energy. Electrical energy, can we able to realize one single moment without electricity? We cannot. Okay, so we always be very much user friendly with this electrical energy. Mainly how it has come, we all know that electricity is produced by a very interesting property of a body, that is called charge. Okay, so if I'm talking about very elementary particles by which an object has made, it is atom, and inside the atom we all know there is proton, electrons. So in that proton and electrons there is a property that is known as charge, and this charged body, if anyhow the charge is disbalanced between two bodies, then there is a energy we have shown, that is known as electrical energy. In the first image we have seen that there is a comb, and in the next part there is some piece of papers. If you comb your hair by using that comb many times, then you go for that piece of papers, then this piece of papers are attracted towards the comb. What is the reason behind it? Simply, whenever you rub it, that it is written here, when two dry bodies are rubbed together, their charged are unbalanced. Initially all the bodies have balanced charge. Balance means equal number of positive and equal number of negative charge, equal proton, equal neutron. But when you rub it continuously, then this equilibrium has been broken and there is an unbalance created. In one body maybe positive charge is increased, in another body maybe negative charge is increased. And then we all know positive charge is attracted by the negative charge or vice versa. Okay, so opposite charges attract. So that phenomena we have seen here, and that is known a phenomena of static electricity. So the first thing, the experiment of the comb we have seen, that is an experiment of static electricity. And apart from that, if the charges are moving from one place to another place, that is known as current electricity, which we often use very much. In the next image you see there, one battery is given along with a switch and wire which is connected to a bulb, and whenever you have on the switch, the bulb will glow because there is a charge, the charges are flowing through the wire. Okay, much explanation based on this image you will get it in class 8. Okay, so for now you have to remember, as we have complete the circuit by using a battery, then the bulb will glow because the charges are moving, and that is an example of current electricity. So whenever we are talking about electrical energy, there is two form of electrical energy. There is two type of electrical energy or electricity. One is static, where the charges are not moving. In the first image you see in the comb there is some yellow dots are given, there the charges are stored. Okay, and on the pieces of paper some red dots are given, that means the charges are stored in that places only. But in this case, whenever we are talking about the battery and the bulb, then the charges should move through the wire. Okay, coming to the next part, after electrical energy, it's a very important thing. In modern days, the modern science and the modern physics based on this thing, that is atomic or nuclear energy. So we cannot imagine that how much energy is stored on a simple atom. Okay, how much huge energy can be stored, from where it has come, how we can use it, that you have to learn little bit in class 10, maximum in class 12. So now you are only class 7, just listen whatever I have told. So this much of energy, that energy can be used in two purposes. One, definitely in constructive, what we have seen in left hand side, in there we can able to use it to produce electrical energy, the huge amount of energy stored in atoms that can be used as a electrical energy. And in next image, that is for destructive purpose. Okay, and we all know in 1945, 5th August and I think 7th and 9th most probably, in Japan, Hiroshima and Nagasaki, in two places, these atomic bombs have been dropped, and we cannot imagine lakhs of people have died, and the people who have not died, they are also suffering from huge amount of genetical disease, and cancer is also one of them. Okay, and generation after generation this disease is carried forward. That is the bad effect of atomic energy. So the energy source is in our hand, but in which side we have to use, that is our choice, whether is in for constructive purpose or in destructive purpose. Definitely we will choose in constructive purpose, but nowadays we always thought that war, we will if war is occurred, we will win, or we can able to make her, we can able to destroy them. So definitely, if I'm telling the truth, war will not make any good things any days. Okay, the story of war, if I'm talking about, it's how much the human civilization is developed, the story of war is also developed. But to tell the truth, war is always destructive. No people can get benefited by the war until unless some people who are actively getting some benefit from it. They are some another peoples I'm not want to discussing here. Okay, we are coming to the physics again. Last part, that is solar energy. solar power, the power of sun, the energy of sun. So light, mainly the light and the heat energy comes from the sun, and we can use it as a form of thermal energy and electrical energy also. Thermal means heat energy, electrical energy too, you all know. So in the first image I have given a solar plate and then a green leaf and along with sun. So here I just want to show you that solar energy is how much nature friendly. If we produce electrical energy by solar energy, then the pollution, the devil of the pollution will be gone forever. But we cannot able to use it. Various purposes are there. In the next part, I have shown you an interesting thing that is known as solar cooker. Okay, we all made our foods by using gas, but solar cooker is an instrument which seems to be looking like box. At the top there is a mirror, so when the light ray incident over the mirror, it is reflected to the box, and if you see in the box there is a pan. On that pan you can make your food, but there is a problem. You have to make your food over your roof, so at very much noon time you have to sit over there and you have to cook food. So it is a little difficult, but using that heat energy, if you do, then it will be nature friendly. Okay, and the loss of gas, it will be prevented. Only that thing we can say. So in this part we have discussed various things about different forms of energy, but in our target or in our syllabus, our concentration is mainly gone over to the mechanical energy. Okay, so the mechanical energy from which we have started, that due to the position, means rest, and the motion of a body, the body will possess some energy that is known as mechanical energy. Okay, so our target to learn about mechanical energy and learn the different types of mechanical energy. Okay, so that is our next part, and to tell the truth, the most important part of your syllabus. Whenever we are talking about the two forms of mechanical energy that we have already told, one is potential energy and another one is kinetic energy. Potential energy is what? Potential energy of a body is the energy possessed by it due to the state of a body or due to the rest or position. How? Now we have to explain a little bit. See, whenever we have seen first image, a man is standing beneath and a stone is taken to a height. Okay, so whenever a stone is taken to a height, that time definitely you have to do some work on the stone. So whenever you have to change the position of the stone from down to a height, you have done some work on the stone, you are applying force on it and it is displaced. And how much work you have done, that is stored on the stone as potential energy. Just now we have told now, due to its state of a body to the state of rest or position. So due to the position, the body will possess energy. Okay, so how you can able to measure it? So it is written, actually it is equal to the work done to bringing the body at rest or position. So how much work you have done on the body, that will be its potential energy. Okay, so if you have taken to the body at a height, on which thing the potential energy depends, that is explained here. That's the factors affecting the potential energy of a body placed at a height. First one, the mass. Okay, simple thing, you see there are two stones we can able to see in the image. First stone, it is already taken to a height. Second stone, it is just kept in front of the man. So if anyone asks you that if both the stones we have taken to the height, for which stone we have to do work more? So simple thing, for big stone you have to do work more. Why? Because it is having much mass. So more mass means we have to apply more amount of force because it is too heavy to take. So more mass, more work done, and more energy is stored. How do you understand it? If you throw the small stone on a substance, on an object from the height, maybe it is not broken. But if you just thrown the big stone, it should broke, because it will have much amount of energy as its mass is more. So first factor should definitely its mass. Coming to the second factor, the height from the ground. Assume you have a stone you have taken to a height, or you have a ball you have taken to a height, assume in third floor, and you have just left it to your friends who is just standing at the ground, and then he should catch the ball, and then you take the ball again, and assume now you have taken to the fifth or sixth floor, in which case it is difficult to catch the ball. So definitely whenever you have to increase the height, we all know whenever we are playing in the field, most of the time we are playing the catches, high catches. So which catch is difficult to hold? Which one is coming from a long height? So more the height, more the work is needed to reach over there, and that's why more energy is possessed. Okay, so if an object taken to a large amount of height, then more amount of heat, more amount of energy is possessed in it. So we can say that potential energy at a height, it depends on two things: mass and height. More mass, more energy; more height, more energy. Apart from this also, I have shown you another image where a boy is just stretching a catapult. So catapult we have all known, bulti, right? So whenever it is stretched, that time due to its position, one energy is stored on it, and that is definitely the potential energy. You might be asking, sir, we are not discussing the factors of it. No, its factors is not discussed now because it is not needed. So we have to discuss the factors where the body is placed to a height, not for stretching. Okay, that one we have to discuss later. Kinetic energy. Okay, and we have come almost to the end of the part. So definitely due to the motion of a body, what energy is possessed in it, that is known as kinetic energy. Okay, and how you have to measure it? So definitely whenever you have done some work to make a body into motion, or to bring a body come into motion, so how much work you have done, that should be stored on it as a form of energy. Okay, and that is kinetic energy. Here I have shown you some images, and there I have shown the body which is in motion. Okay, so in three images you see everything is in motion, and as the body is in motion, it should possess some energy. Okay, so what are the factors on which the kinetic energy depends? First one, mass of the body. Assume if a cycle is coming with a speed of 20 kilometers per hour and just coming and just collide with some person, then what will happen? Yes, the person will get injured. But assume instead of cycle, if a car is coming with same speed and just collided with the person, in which case the person will much injure, definitely in the case of car, because the car is having much mass, more mass, so more energy is stored. For cycle, less mass, less energy is stored. And next one is speed. Assume a car is coming and colliding with an object with a speed of 20 km per hour, then what will happen with the object? If the same car, it is coming with a speed of 70 km per hour, okay, so definitely the effect will more there. So more the speed, more the energy. So the two things on which the kinetic energy of a body depends, that is mass and speed of the body. Okay, so that is the whole story for today. and we have learned many things about energy. If you have any doubts, definitely you can ask. Okay, in the next class, we have to discuss about the relations between kinetic energy and potential energy and how it converts with each other. So till then, thank you very much.